Hey, welcome back. So, in the previous lecture, we have seen how to work with sequences. For ex- that is for creating arrays from our pre-existing data. Okay, so this lecture will be about the arrange function, mainly with the arrange function. And basically what arrange does, it basically returns an end array object which consists of evenly spaced values within a given range. Okay, so it's much more like the range function that we have seen in Python. Okay, which is in Python also we do have steps, but here if you look that the only thing that it differs here, beside the name, that is the range function. Okay, what we have here is like, for example, this is our arrange function, and let me just start it from here. So we got our start point. Okay, we got our start point. I am just writing it as short. Then we got our stop point. Okay, so we have our stop point. Then we do have one more thing which is same as the range function in Python, which is the steps. Okay, we got steps here. Okay, so for example, by default the steps is default set it to be 1. Okay, so for example, if you start a range from 0, okay, we have seen this previously, the use of arrange function. Okay, if we start from 0, it goes to 1. Okay, it's a one step. But how about it changing it to 2? Okay, if we change it to 2, it doesn't go to 1, it just go directly to 2, then 4. Okay, then 6. So it becomes a even range, even steps up there. Okay, as you can see, I mean even by even numbers only. Okay, and it just goes on until the end occurs, the end that you have defined here. Okay, the fourth thing that it has is the d type. Okay, so d type is, I believe, way much common in most of the functions in NumPy. Okay, so this is a very basic structure. This part belongs to here. Okay, so we got our start point, we got our stop point, then we have steps. Okay, we got steps here, then the d type. Okay, so that's a very basic function structure of NumPy arrange. Okay, so let me just clear out this screen. Okay, so we have seen how to create a very basic arrange using arrange function. Okay, so we have imported our numpy, I believe. It's run, so let me just check it out first. So x equals np dot arrange, and let me just create a range of 5, and let me just print this. Okay, oh yeah, np is not defined, I know that. So let me just again import this because I've closed the actually I've closed the this notebook. Okay, then actually I haven't run the previous cells. Okay, was to do that you have to run the entire cells again, but I'm not going to do that. Okay, so let me just import numpy. Okay, as np here. Okay, so that's the thing that you need to remember working with notebooks. Okay, if you haven't run the previous cells, and you have actually, if you have closed this notebook and reopen it and actually close that server entirely and just go and create the server, then open your notebook again, and if you haven't run these previous cells, it shows error. Okay, so let me just hit enter, and now we got our array created. Okay, so this is our array here. Now if we want to change these types from integer to floating point, how we can do that? Just pause the video and just go do it by yourself. Okay, so you're back. So I know you have created that successfully. For those who don't able to do this, let me just then for those peoples. Okay, so np dot arrange. Okay, and let me create a range of let me create for 6. Okay, I'm going to create it for 6. So d type equals what? It's float. Okay, so float, and let me just print this again. Okay, so x. Boom, we got our floating point values here. Okay, so each and everything is now converted to floating points. So how about introducing a step? Okay, so we are going to introduce a step, very basic step. So let us see how to work with steps. So x equals np dot arange. Okay, that's a function. Then starting from, I believe, from 0, let's just start from 0. Okay, up to 10. Oh, okay, let's say up to 11, comma, and let's take steps of 2. Okay, so print x, and remember x isn't actually storing anything at all, it's just a reference. Okay, so now as you can see, 0 2 4 6 8 10, by default it is set it to 1, and if you don't write that, it doesn't matter, it is by default set to 1. But if you define the step by your own, how much steps should it take, it goes something like that. Okay, so we created our a range here, and let me just zoom out the screen. Okay, okay, so how about creating a reverse? Okay, so if you want to do the reverse thing, what I can do, or what we can do, so just stop the video, just, I mean, just pause the video and just go and do it by yourself. Okay, and come back after you're done. So I hope you have done it successfully, but let me do it once again for those who didn't able to do that, how to do this thing. So a range. Okay, then let me just put this same thing here, 11 comma, I mean up to 0, and let's take the stride, I mean the steps of -2. Okay, so print that result on the go. So it basically, what it does, it starts from 0, the range, and it goes down to 0. Okay, I mean it starts the range from 11 and then goes down to 0 by taking the different, by taking the steps of 2. Okay, so your result, it starts from 11. Okay, 9 7 5 3 and 1. Okay, so as you can see now, it is working. And if I do remove the -2, let us see what happened. Let's check it out. Okay, now because it is going to take by default 1. Okay, so it's our empty nd array. Okay, it's basically consists of nothing right now. By default it takes 1, but if you want to go down, you have to define the step. Okay, you have to define the step by yourself, you have to override that by the default step here. Okay, so that's how you can create a reverse nd array. Okay, so our next function is called the linspace, lin space. Okay, so this function, okay, so this function basically what it does, it is pretty much similar like the arange function in numpy, but it actually divides the number of evenly spaced value. Okay, so if you do have an array, it actually, if you actually have a range, it actually divides those number evenly spaced values. Okay, the interval is specified, you have to specify the interval and what it has with it. So let me just write it. So linspace. Okay, we got this function. Then linspace is pretty much same like the arange function. So starting point, then the stop point. Okay, and after stop point, what we have, our number, the number of evenly spaced samples to be generated. Okay, so we got our number, and by default it is set it to 50. Its value, the default value is 50. Then we have our endpoint. Okay, and endpoint is default by true, it is true by default. Okay, so we got our endpoint, this is not the stop point but the endpoint. Okay, and by default it is true. Okay, its value is I'm sorry about that, but yeah, true. Okay, and endpoint, after endpoint we got our something called red step. Okay, it is also true by default. It returns it basically it actually returns samples and step between the consecutive numbers. Okay, so we got red step. Okay, red step. Sorry for my writing. And at the last we got the same thing, which is called d type. Okay, so that's what our linspace function looks like. Okay, so it got our starting point, the stop point. Okay, where to stop the number. The number basically is the evenly spaced samples which is to be generated. Okay, and it is by default set it to 50. Then we got our endpoint, which is true by default, and the step value is actually included in the sequence. If false, it is not included. Then we got our red step, which actually returns the samples and the step between the consecutive numbers, and we got our d type. Okay, so that's the basic structure of linspace. Okay, and let us demonstrate it by practically. So x equals np dot linspace. Okay, then let me start from 10 to 20 and step of 5. Okay, and let's just print this. Okay, so print x. So this is what linspace does. It actually created. So basically we do have our 5 values here, and it evenly distribute those 5 numbers between 10 to 20. We got 5 numbers and they are evenly distributed. Okay, so if we actually makes our endpoint false, let's check that out also. Okay, so let me create x equals np dot, let me zoom out a little bit. So okay, so linspace. Okay, then again 10, 20 and 5. Okay, and let's set the endpoint equals false. I'm sorry, it's bigger one because it isn't highlighted, so I know I'm writing the wrong. So just print x. Boom. Now endpoints are removed, as you can see from our previous example. Now the endpoints are not there. Okay, but it is now evenly distributed. We got 5 values which are evenly distributed right now, so 10, 12, 14, 16 and 18. Okay, so let's do something more. Let me think first. Okay, so let me do this same example, but now let us check about 6 values. Okay, so let's test it out. Okay, now we got our 6 values without setting the endpoint to false, but we got 6 values. Okay, the previous example, if you can see that here, the previous example having 5 values. Okay, without the endpoint. The next is with the endpoints. In the next example we have our 5 values, same 5 values, but we endpoint. And in the third example we got 6 values, but now they are evenly distributed. Okay, so that's what linspace does. And now let so now let's check what red step is. Okay, so if red step is set it to true, what it does, it basically returns the sample. Okay, it returns all the samples. These are the samples and the step that it has taken. Okay, what step it has taken. For example, here we have the step of 2.5. Okay, so we got 2.5 of step and we don't know, we have to test it out manually. But if the range is so long and if the numbers are so big, how we can think about the step, what step it has taken? So that's why we got our red step here. So what the step that the program or the computer has taken to make a equal space here. Okay, so let me just set the red step to true. So np dot lens step. Okay, so lens step, then let me do it for the same example, 10 to 20 and 5. Okay, and let's set the red step. Okay, red step equals true, and let's print it out, print x, and let's see what happens. Hmm. Dot lens step. 1 second. Lens. I'm sorry for that. It was Linspace. Okay, so I know things happen, but now as you can see, let me just, yeah. So we got our array. We got those five values, 10 to 20, and those five values are 10, 12.5, 15.0, 17.5, 20.0. And we got our step. Okay, what step that the computer has taken, which is 2.5. Okay, and let me do another example. Okay, so let me just copy this and paste it up here, and let me change this to 1 to 2. Okay, and let us see what happens. 0.25. Okay, and how about the example of getting six values? So let us see what steps it should take, and it take. So it's 2.0. Okay, and how about getting here, let's say three values? How about three values? So five steps. Okay, so that's how Linspace is so that's how Linspace works, and that's the capabilities and the power that it provides to us. Okay, we can create equally distributed spaces, number of spaces. Okay, we got a long range of numbers, but we can create them, we can divide them equally. Okay, and we can also get the step, what step that the computer has equally divided. If we want to check how to divide maybe 1,000 numbers that are starting from 1 billion to 10 billion. Okay, um, uh, we need to check out between those range, we need to check out if we divide those numbers into 1,000 numbers. Okay, and what's the step and what's the range that they can be equally divided. So you can check it out using this function here. Okay, now next we have another function which is called log space. Okay, so it basically works on the log, okay, mathematical log values. And actually it is pretty much same like the Linspace, but here we got our one thing called which is base. Okay, so here the only thing which differs here is the red step. Beside the red step we have here our base, so we can define the base, how much the log, what the base of that log. Okay, and the num is same, it is by default for 50. Okay, so let's do the practical implementation of this function. So let me take a equals np dot log space. Okay, yeah, I think I write the correct syntax, log space, yeah. So let me start it from 1.0 comma 2.0. Okay, then let me set the num equals 10. Okay, and let me just print out this. Okay, so print a. Okay, so these are the 10 values between the log space of 1.0 to 2.0, and by default the base is set to 10. Okay, it is by default to 10. So let me just create another one. Okay, so let me np dot log space. Okay, then let me start it from again 1.0, and or maybe let's take 10. Okay, so 10, 20, and let's set the numbers to be 10, and let me set the base to 2. So let's check out for base 2. Okay, which is the binary log. Okay, so print a. So these are the values that we got here. Okay, so these are the values in base 2, the 10 numbers between 10 to 20. Okay, we can also let me take another example if you couldn't understand, because these look so horrible for the first time users. Okay, so let me go from 1 to 10. Okay, So they are much more beautiful. Okay, so we got our values here. Okay, so now you understand how the log space works. Okay, so that's for this lecture today, and next lecture will be related to indexing and slicing in the array, NumPy array. Okay, and I hope you're enjoying the session, and if you have any doubt, if you have any question related to anything, or you find something on the internet while googling or while searching on internet, if you are doing something, if you found something new or you don't understand what is that or what that is, so just ask in the Q&A section. Okay, and as always, thanks for watching. Bye.